Like number 2.
Okay, so you want me to look at 2?
Yeah, I don't know how to set them up.
Okay.
I got it wrong every time.
Hold on. Let me switch these. Oh, no, that's not going to help. For some reason, my computer is going stark raving crazy here, and it won't place number 2 in the right spot. Okay, there, now we go. If I could get rid of this picture right here, I could see what's happening. Oh, God. How does that picture go right there? Right there. Okay, now I can at least see the picture. Can you see that thing on my screen?
Yeah, it went away though.
I know. For the moment. Alright, so what's this? 3z what?
3z minus 10.
Okay. And this arc measurement is 2z plus 40. What do we know about inscribed angles? This is an inscribed angle because its vertex sits on the circumference. Okay?
It's 2 to 1.
It's 2 to 1. So give me an equation I can write.
2 times 2z plus 40.
The wrong way. The angle is half of the other. In other words, if I tell you that this is angle, if I say that's angle 1, what's the relationship between angle 1 and 2z plus 40?
2z plus 40 is, or 1 is 1/2 of 2z plus 40.
Correct. Whereas the first time you told it to me, you had 1 as being twice 2z plus 40. So 1 is, one moment, I've got to close this out, and I got to open it again because it's not letting me look at it. All right, they're not letting me write. All right, so you can figure out how to solve that? Hold on a minute. Yeah, I'm sorry. They didn't want you to just solve for z. However, solving for z is solving, one moment.
So it would be 2z plus 40 divided by 2.
Well, the way you should do it is write it as you see it. Excuse me, I apologize for this. Okay, we'll write it with the mouse. There we go. Now I finally got it working. So write it the way you see it, starting with the angle. 3z minus 10 is equal to 1/2 of that arc. And if you always do it this way, then there won't ever be a problem. And in other words, don't start with the arc and try to figure out what it is relative to the angle. Always know that that inscribed angle is half of the arc that it intercepts. Now, do you have any problem solving for z?
No.
Looks like you got minus 90.
Yeah, I just put an answer because I didn't know what I was doing wrong.
Okay, but an angle cannot be negative in this context. You can have negative angles when you talk about
I know,
but you can't have negative angles in this thing. So if you come up with a negative angle, you've done something wrong. What's the first step to solving this equation?
Well, you've just set it up right, and I didn't do that.
Okay, so you don't have any problem solving for C.
No, yeah, I got that. I just have to, if it doesn't make sense, then he takes points off.
How are we going to solve for Y?
Well, once you have Z, you plug it in, and then you subtract 165 and whatever that angle is from 360.
Okay, cool. Which one next would you like to look at?
Let's do 4.
4? Okay. So 4, we're trying to solve for X, and we clearly weren't given that 57. But notice that we have a diameter line in number 4, right? This line right here that goes through the diameter. So what does that mean about the total arc measurement from that point where my cursor is all the way around to the other end of the diameter? What does that measurement have to be?
57.
No? Well, I meant from the end of the diameter all the way around to that point. What is that measurement?
Oh, 180.
And since we know 2 out of those, we just have to subtract 58 plus 65 from 180, and that's how we get 57.
Okay.
Once we have 57, now we can go back and we can get angle A. Tell me the equation I should write for figuring out angle X.
57 divided by 2 equals X.
Okay. What else?
5.
Okay. Is that middle line a diameter?
No, I drew that in. It's only a radius.
Right, but if we extend it, it becomes a diameter, and that's important. In other words, you want to extend it because the only formulas we know are ones that have a secant line and a tangent line. Well, if we have that situation, we know that this angle theta is half of the difference between the big arc that it intercepted and the little arc that it intercepted, right? So if we didn't extend it, in other words, if they gave you the problem and the problem was just this, well, we don't really have a formula for that. So we have to continue that to figure out where it intercepts the other side. Now they've given us theta. That's 34 degrees. And they've given us, let's see, what else is in this picture? We have this here, and then we have this there. And they give us that. Well, what did they give you here? It's hard for me to tell what they gave you and what you wrote in.
I wrote that in. They only gave us 34 and then 4a minus 16.
Okay. So they said this was a right angle, or you drew that in?
I drew that in because it's tangent line.
See, I don't think it is a right angle.
But it has to be because it's a tangent line.
It's a tangent line, but it's not connected to a radius. In other words, the radius would come from the center. Isn't the center of the circle right there?
Yeah, I thought.
So if I drew a line from the center to the point of tangency, that would be a right angle. But this is not. However, we do know something about this picture. Let's let this be x. And what is this? If that's x, what is that?
That's me 68.
No. If this is a diameter line, what's the total arc measurement from this point to that point on the bottom? This arc measurement right here.
180.
Yeah. All diameters split the circle in two. So you have a semicircle, so that's 180. So if this part of that arc is x, what's this part over here?
X, 180 minus x.
180 minus x. Now I know both arcs that are intercepted. That arc is, the big arc is 180 minus x, the little arc is x, and what's the formula? What's 34 degrees have to be equal to? What's the general formula?
34 square, wait,
No.
wait, which one? Equal 180 minus x minus x.
Good. That it?
Divided by 2.
This is why I tell everybody to start out the equation by saying 1/2. Because half the students forget to divide by 2. If you start off by saying 1/2, that'll never happen. And all of these relationships almost are 1/2 or 2 to 1. So you don't want to ever miss the 1/2 multiplying or dividing by it, okay? And the way not to do that is by listing it first. It's like if you said to me, what's the area of a triangle? I would say 1/2 base times height. I would never say base times height divided by 2. It's just the way I remember it. If I always stick the 1/2 in front, then I'm never going to forget it. Now, does that allow us to solve for x?
Yes.
Yeah. So we get 68 equals 180 minus 2x. I'll bring the 2x on the other side, move the 68 to this side. I get 2x is equal to 112. So x is equal to 56. So this measurement from there to there is 56. Let me label it in my drawing. Now that we have that measurement, we can solve for A, right? How do I solve for A?
It would just be
Start with the
56
angle.
divided
Start with the angle on the left side of the equation.
4a minus 16 equals 56 divided by 2.
Okay. That solves for A. Is that all we had to solve for here? Yeah. The secret, the hard part of this problem was this little, whenever you have this situation here where one of the lines is a tangent line and the other is either a radius line or a full diameter, you always have this big arc and this little arc being supplementary to one another. Because this arc measurement is always 180, the entire arc. And the two arcs that get intercepted by the angle are the big part of that 180 arc and the little part. So if I call this x, this is always going to be 180 minus x, which means I can always solve for the little arc and the big arc with this problem with just that angle, as long as I know that's a diameter line. Okay? And in this problem, once I solve for the little arc, I've done all the work. In other words, now it's an easy problem. All right, what next?
Can we go to this?
Yes, second page. Which page? The upper right or the
no,
lower left?
The third.
Third?
No, up to the right.
I'm sorry.
No, the other one. The other one.
This one here?
Yeah.
Okay.
I don't know how to do the proof or the 22.
Well, let's look on 22. May not. We can go back and look at the proof also, but let's look at 22. It looks like it's going to take us 10 minutes to do 22. So there's a circle. Let me draw it. With radius ZM. That has to be Z. That has to be M. And another radial line that's ZN. I knew Z had to be here because it was used to describe both radiuses. If Z is 4 minus 6, that's the center of the circle. M is 16 comma 3 and N is minus 5 comma 6. Give me the general equation for a circle.
X minus H squared plus Y minus K squared equals R squared.
Write the equation of a diameter of this circle that does not include those points. Okay. The equation of the diameter does not include M or N. Well, I must be confused here. First of all, I've never had anybody ask for the equation of a diameter. Okay, why is the answer not y equal minus 6? Horizontal line, you define it by y equals whatever the y coordinate is. Doesn't include n or m, and it's the equation of a line, of a diameter. But somehow I feel like they want the equation of the circle, even though they don't ask for it. What do you think?
I mean, that's what I thought, so I just wrote what I thought.
Was this a test? Did you get it scored?
No.
Okay.
No, this is homework.
Okay, well, you got the equation of the circle fine. X minus 4 squared equals y plus 6 squared. Now, that equals 225. Where'd you figure out that the radius was 15?
Well, I just did, below it, it says 14. I plugged in the points and got r squared equals 225, so I didn't, like, unsquare it just to square it again.
Okay, all right. That's a good way to do it. You could also have done the distance between 2 points formula. That's probably what I would have done. In other words, I would have taken either m, the distance between m and z, or the distance between n and z. They're both radial lines, so that's going to give us the radius. But the way you did it was perfectly acceptable. In other words, this is the equation of our circle, and I know this much of it. Well, if those 2 points are on my edge of my circle, then they have to satisfy this equation. So by plugging in one of these points for x and y, I'm going to be able to solve for r. So you got r as 15, or r squared as 225. What could they possibly have meant by the equation of the diameter of this circle? I don't know. You see why that seems to be the answer to their question?
Yeah.
I also could have put a vertical line. The equation of the vertical diameter. What's the equation of that vertical diameter?
16.
What's the
Right?
equation of it?
Oh. X equals negative, no, 16. 4?
That's the x-coordinate of the center, correct?
Uh-huh.
If I draw a vertical line through that, I get x equal 4. That's my vertical line. It's a diameter of the circle, and it doesn't go through n or m. So their question doesn't make a whole lot of sense. I mean, there's at least two answers that I can come up with in 5 seconds. And then, of course, you have all of these, which would be different slopes. So each of those lines would have a different equation. But certainly coming up with the equation of the diameter was a piece of cake, and coming up with the equation of the circle wasn't that hard either. You did it just fine. It just kind of depends on what they meant.
Uh-huh.
It's hard to believe they actually meant the equation of a diameter of this circle. So we got a couple minutes more. Is there another one on this page you want to look at? Shall we look at the proof?
Just the proof.
Let's just see if I can get us started on the proof. If I can show you conceptually what you're going to do on this proof. CD is tangent to both circles. AB is a common chord of both circles. And M is the midpoint of CD. And that's what we're trying to prove. Well, the first thing we know is that we're creating right angles, correct? In other words, all tangents that are connected to a radius create a right angle at the point of tangents. So this angle is right, and that angle is right. AB is the common chord of the two circles. What did you write here? Angle PCM and MQ are right. Okay, that's correct as a second step. And now you say that line AB is congruent to itself because of the reflexive property. How much of this did you draw in?
I just drew radius, or I guess radius from M, like Q and P to M.
None of these lines were drawn? In other words, you drew in all of the lines here except for AB?
No, I didn't. I just drew lines. Wait, yeah.
Well, you drew CP, you drew PM, you drew MQ, and you drew whatever that radial line is. It may not be the way to solve this.
He told us a hint today, so he said, like line CM, like using the formulas of a tangent and line AB, the chord line AB. I don't know. It's
Ah, yeah, okay. All right, I think I see now. Um, hmm, let me think for a moment. To prove that M is the midpoint, we're going to have to prove those two triangles are congruent, right?
mhm.
In other words, if the two triangles were congruent, and certainly they have a right angle and a right angle, so I don't have too much more to prove that this triangle is congruent with that triangle, which would make M the midpoint, because it would make CM the same distance as MD, or whatever that letter is, D, I think. So probably proving congruency is what we want to do. And you say AB is perpendicular to CD. It sure doesn't look perpendicular.
I was just guessing because I just needed credit. I had no clue
Yeah,
how to
no,
do
I
it.
don't think it is. I don't think it is. Um, Let me think about this problem for a second. To
I can always
prove,
ask in class because we don't have a test tomorrow.
okay, you may have to because we're about out of time here, but let me think about it for 2 more seconds before you go. AB is a common chord of the two circles. What does that mean? That means, wow. Wait, I'm going to have to think about this. You want me to
Okay.
call you back tonight, or you want to just ask your teacher about it tomorrow?
I can just ask him tomorrow.
Because this might be one of those things where if I think about it for 20 minutes and I stare at this picture, that I might discern how I'm going to prove those two triangles are congruent. They actually have to be. No, they don't have to be congruent. And in fact, they're not congruent, because this line QD is not the same radius as CP.
Mm-mm.
So they're definitely not congruent with that regards. Um, which makes me doubt that M is the midpoint of CD. I don't know. I'm going to have to look at this one a while. It's not so much the fact that it's a proof. Even if this was not a proof, it'd be a little difficult to figure out as to why M is the midpoint of CD. Can this have anything to do with, obviously that chord is extended to get to point M, right? In other words, MAB is a straight line, is that correct?
Mm-hmm.
All right. Um, ah, that says something about the angle. Let me just keep you for 2 seconds more. There's CD. There's that line. And we know what you said was that when you have a tangent line and a secant line, well, this angle, 1, is equal to the difference in the two intercepted chords, or measurements of the arc, right?
Mm-hmm.
And same on the other circle. Is the angle DMA intercepts these. Well, I don't know how that's going to get us anywhere, though. I don't know. That probably is the direction you want to go here, because that's what this whole subject material is about, right? It's about having a secant line and a tangent line intersect outside of a circle, and the angle they make has something to do with these two arc measurements of this arc and the outside arc. I know that that angle is 1/2 of the big arc minus the little arc. So you might be able to get somewhere doing that. I don't know. I'm going to have to look at it longer. But good luck to you tomorrow.
Thank you.
All right, great. Talk to you next time.
All right, bye-bye.
Bye-bye.